Good afternoon, everyone. My name is Matt Miller, and with me is Jeremy Erickson. We are representing Duo here today. And in the next 40 minutes or so, our goal is to introduce you to and demonstrate a new browser API that's here to change the way we authenticate users. It's called WebAuthn. So what is WebAuthn? Simply put, WebAuthn enables users and developers to easily leverage public key cryptography to provide assurance. The users are who they say they are. As with any login system, you always want to make sure that you are showing a user the correct information. You don't want somebody to log in as somebody else and get access to that information. So in the past, where we might use usernames and passwords, WebAuthn is going to offer an alternative to that is going to only grow in adoption in the days to come. And so our strategy, or our plan here, is to kind of show you how it all works, so you can dip your toes in the water, and we can offer some additional resources for you later on to help you get started down this path. So yeah, as I mentioned, WebAuthn uses public-private key pairs to help users prove that they are who they say they are, and that servers can develop trust that those statements that users make are true, cryptographically, mathematically. And so the nice thing about WebAuthn is that it's fairly new in terms of APIs, but it's been out for about a couple years now. But adoption has finally reached critical mass with support in all the latest browsers, including Chrome, Firefox, Edge Chromium, and Safari. And this includes just about every mobile platform you can think of as well. Now, WebAuthn offers a more secure and convenient alternative to two-factor authentication. You may be used to things like SMS codes that you get texted, or even one-time passcode generators, those 6-digit codes that you can on a rotating cycle. WebAuthn seeks to replace these, as these means of two-factor authentication can be bypassed by things like SIM swapping or through phishing. Now, the nice thing about web authentication is that it's a technology backed by cryptographically secure hardware. And this hardware is available on just about every smartphone in the last few years, and on on Apple products. You may be familiar with the Touch ID button, and on Windows Hello is another one. And so the technology to enable all of this is more common than you might think. Now, going back to the concept of providing assurances of identity, WebAuthn accomplishes this in two kind of modes. The most basic one is user presence. Now, part of WebAuthn is that a user has to physically interact with a authenticator that they are choosing to use for registration or login with WebAuthn. And so user presence is a guarantee by the authenticator that a user was physically there to interact with it. And so this makes it difficult for bad actors on some remote, the other side of the planet, try to impersonate you, because this server will be able to see, well, no one was actually present for this, so it's not legitimate. Now, the next level of that is user verification. User verification combines user presence, which is proof of something the user has, like a laptop, phone, security key, with one of two other things: something they are, biometrics in the case of Touch ID or Face ID, fingerprint scanners, those kinds of things, or something they know. In platforms that don't support biometric identity, a PIN is just as sufficient to prove user verification. And what's nice about WebAuthn is that it's a pretty flexible API. There's kind of three modes or three ways you can deploy WebAuthn. You can use it as a second factor in addition to traditional username and password. That's called 2FA. There's also the concept of password lists that WebAuthn enables, where you can essentially, the user only enters a username or an email address, and then the password entry is replaced entirely by an authenticator interaction. And you could even take this one step further and go username lists, where the user doesn't even have to enter a username. It's the authenticator. Once the user has gone through registration and created an account, it's the authenticator that keeps track of the user's identity. And so the server can completely kind of forget about usernames or passwords completely. And that's a very kind of like the highest level of integration with WebAuthn. And so these three modes really represent the future. We believe they represent the future of website authentication, because it fundamentally allows website developers to eliminate passwords completely. And so this is going to mitigate a lot of issues related to password reuse. If you know, in the very unfortunate incident that your user database ever gets dumped, if you're leveraging WebAuthn for user authentication, there's no passwords to leak out. And so that, and in addition, the information that the servers store about these keys, even if they get out into the public, they're useless without the private key that is stored on the device. And Jeremy will go a little bit into more in depth on the crypto side of things, but and all of this passwordless future that we're kind of that Duo is betting on, and Jeremy and I both believe in, is enabled by technology that users already have. So Touch ID or Face ID on iOS or Mac OS all play with this. Fingerprint scanners on Android phones are all you know, something that users have access to, and they don't even really, you know, have to think about it. Windows Hello enables this on desktops, and there are even a whole class of secure hardware in a USB form factor that users may wish to leverage if they want to have, you know, kind of a key that they can take from machine to machine, as opposed to being tied to a single device. And so really, this represents a seismic shift in authentication just because of how it fundamentally changes authentication as most people know it, where, you know, proving who you are requires a combination of a username and password. This kind of turns that on its head with, you know, secure hardware. And so adoption is growing. You know, GitHub supports this. Google allows you to use WebAuthn Power 2FA to sign into things. I believe Facebook has deployed it as well. Azure is, Microsoft is a huge player in this space, and so Azure has strong integration with this technology. And so WebAuthn as a feature is a great way to kind of get started into web security, and demand for it is only going to go up. So if you're looking to get into this space, Web Authentication API is a great place to start, and can, you know, we think it's a perfect opportunity to fast track your career aspirations in that space if you wish. So if you want to get involved, there's several resources. We're in our deck, which will be available to you after this. We're going to have lots of links in there for you to check out. The W3C, the World Wide Web Consortium, which is the standards body responsible for a lot of the the APIs that are available in the browser, has a community group, a WebAuthn adoption community group that anybody can join, and you can participate in that. The goal of the community group is to, it's essentially a developer-friendly place where we're, and I'm a member of it, so our goal is to kind of collect and offer up what we find are best practices, and the idea is that a developer can kind of come to this community group and the resources that come out of it to get a jump start on working with this technology, because there's lots of nuances to it. But if you decide that that's a route you want to go and you want to participate, or even if you don't and you're just looking for open source projects in the space to assist with, Practical WebAuthn is one of those deliverables out of the adoption community group that is taking contributions and is looking to kind of become a central place for developers to go to learn more about this technology. And then eventually, if you decide you want to go down this rabbit hole and get more proficient in it, you can become a driver of implementation in your organization or your community. And so maybe you see what WebAuthn is capable of, and you're like, oh, hey, this is great. Like, everybody should be using this. This presents a really great opportunity for you to kind of be a vanguard of higher security in your organization. Now, before I turn things over to Jeremy to show you WebAuthn in action, I want to highlight this slide here. There's 2 columns of resources that we've prepared that we think are going to be great ways to get started down this path. On the left-hand side are websites that focus on, they get into the nitty-gritty of what is actually going on behind the scenes when WebAuthn is in use and when your users are using it, and as well as user UI considerations, because there's a degree of user education because of how new this technology is. On the right-hand side are libraries that we believe are exemplars of production-ready libraries so that you can incorporate these into your projects. Full disclosure, Simple WebAuthn is my, I personally wrote and maintained that library, unaffiliated with Duo, excuse me. But it is at a production-ready state for your Node projects in 100% TypeScript. And passwordless.dev is a .NET variant. So if you happen to work in that stack as well, it's another great library to kind of look at. And they have a great example of the 3 different modes of WebAuthn integration as well. So, and so with that, I'm going to stop presenting. And I'd like to turn things over to Jeremy so he can show you all of this in action.
Great, thanks, Matt. So today I want to show you what the WebAuthn experience looks like, and then go into what's happening under the hood a little bit more. So at an incredibly high level, like the highest level, what we're trying to do with this is to move local login. Here's an iPad. I'll try not to get the reflection on camera. And the experience where you scan your fingerprint, well, of course. Come on, there it goes. Well, that was less polished than I was hoping. But the experience where you can just scan your fingerprint and get into your computer or your phone or your tablet, and we want to move that to the web so that you can do the exact same thing and log into various websites. So I have here a YubiKey. Hopefully you can see this. This is just a plain USB device. Along the top here, it has a little capacitive sensor that I'm going to be touching in a minute. So when I say I'm touching my YubiKey, I'm just tapping this sensor. I'm not doing anything fancy with a fingerprint or anything. And I'm going to share my screen as well. All right, it looks like that's shared. And what I want to show is WebAuthn.io. WebAuthn.io is a demo website that allows you to interact with WebAuthn and explore different options that you're allowed to set. So you can click on advanced settings and go down and choose different options so that you can test out how WebAuthn works on your own. You're all welcome to head to that website and play with it while we're presenting if you like, as well as any of the other websites that Matt shared earlier, like passwordless.dev. It has a very similar experience. So the same thing that I just did, logging into my iPad using my fingerprint, I want to do the same thing with my YubiKey. So I'm going to go here and I'm going to register for a new account, and up pops this browser modal that says use your security key and touch it. So I'm now going to touch my YubiKey and I'm done. I've now created a new account. I've registered for a new account under the username Jeremy. And so let's say I refresh the page. I come back to the site later and I want to log in to my website, in this case, WebAuthn.io. So I can type in my username, Jeremy, and click login. It's going to prompt me to touch my security key again. So I'm going to touch it. And ta-da, I'm now logged into this website. And that is the WebAuthn experience. So let's go back and let's talk a little bit about what's actually happening as part of this process. And there's 3 major components for this. There's the authenticator device, which is the YubiKey in this example. There's the relying party, which is the website you're interacting with, which is WebAuthn.io. But I'm going to use the term relying party because that's the term used in the WebAuthn specification. And there is the browser, and the browser plays a critical role in this protocol as well. So let's start with the authenticator. I have my YubiKey, and what is it doing under the hood when I go and register a new account? So when I hit this register button, what's going to happen is a request is going to get sent to the YubiKey, and the YubiKey is responsible for generating a public-private key pair and keeping the private key stored on the hardware of the YubiKey itself. It never gets exposed to the computer or the website. The private key can never be exported off this device. If you're not familiar with public-private key crypto, just know that the private key is something you need to keep secret. And because you're the only one who has it, you can sign messages, similar to physically signing a message. so that somebody knows that that message came from you. The public key half of this public-private key pair can be shared with anyone, and it can be used to validate the signature was generated by the private key. Because you're the only one who has access to the private key, the signature must have come from you. So by distributing the public key around, other people can verify your identity by validating that messages signed using the private key come from you. Okay, so the private key stays on the YubiKey, and the goal is to get the public key to the website, the relying party, so that in the future, we can give WebAuthn.io, the relying party, a signature, and then it can tell that it's us. It can tell it's you and log you in. So what's happening when you tap your YubiKey, and it'll prompt you to generate this public-private key pair, and it'll ask you to either like click continue or to touch your YubiKey. And what you're doing there is you're expressing intent. You're giving the authenticator device permission to generate a signature and send it to the server. It's really important that this doesn't happen automatically, since that signature is what allows the server to verify your identity, and you don't want someone else to be able to generate one automatically without your knowledge. So that's really all that the YubiKey or the authenticator device is doing. So let's move on to what the relying party or WebAuthn.io is doing. So during registration, when I click this register button, what's happening first is that the relying party is requesting a new credential from the user or from the authenticator. The authenticator generates that key pair, passes the public key and another piece of data called a credential ID back to the relying party. And the relying party holds on to that public key for validating later messages. And it hangs onto the credential ID so that it can request a specific credential later on when you hit login. So then during login, the website, the relying party requests the authenticator uses that credential that you created earlier to sign a request stating that the user wants to log in. The user specifies their intent again by touching their YubiKey, which allows the authenticator to generate a signature over that message. The signed message is returned to the relying party, which validates the signature. And if it checks out, lets the user log in. Now, during both the registration and the login flows, there's an additional piece of critical credential metadata called a challenge. This is generated by the server, and it's a sequence of unpredictable random bytes that are part of the message that the authenticator signs over. And the reason that this challenge exists is because it prevents an attacker who's able to see or capture a previously used signature from being able to replay that message to log into the website as you, or to forge a new message using an old signature, attaching an old signature to a new message. The signature is tied to a specific message in part because of that random unpredictable challenge. So that's what the relying party's role in this is. Now let's talk about what the browser does as part of this flow, because that's really important, even though ultimately this is the website using your authenticator device to log you in. There's a critical piece in the middle that the browser is doing. So the browser, besides facilitating the communication between the website and the authenticator, the browser is responsible for ensuring that the user doesn't get phished. One of the additional metadata fields in the request is the RPID, the relying party ID. And the RPID is set by the website, and it's supposed to be the same as the domain the user is on. So for instance, I'm on WebAuthn.io, and when I go through this registration or login flow, the request that goes back to my authenticator through the browser will have an RPID field set to WebAuthn.io. Now, the authenticator uses this RPID field to pick which credential to use to sign the response. Now, your YubiKey could end up holding credentials for WebAuthn.io, passwordless.dev, Google, Facebook, Twitter, pick your company that's implementing WebAuthn, and it'll hold credentials for all of those sites. So it's really important that it uses this RPID field to use the correct credential. Now, the authenticator device can't actually see what website you're on. So it's up to the browser to monitor what the RPID field is when this request goes through, and then check it against the domain of the page that you're on. If it doesn't match the page, the browser needs to block the request. If the browser didn't do this, then for instance, a user could be unintentionally on badguy.com, and it could ask the authenticator to sign a message, and it could set the RPID to goodguy.com, and the authenticator can't see what site you're on, so the authenticator would happily sign the assertion saying, yep, here you go, I'm logging into goodguy.com. And then badguy.com could take that assertion, turn around and give it to goodguy.com and log in as that user. That would be really bad. So that's the critical role that the browser is playing in all of this. Now, I want to turn back to a topic that Matt introduced earlier around user presence versus user verification, because this comes up when we start talking about passwordless authentication. Now, you didn't see me use a password earlier when I logged in here, but that's mostly because this is a demo site that will let me do something kind of insecure to log into the demo site. But for true passwordless authentication, we really want to be using multiple factors to log you in. And a user presence check is just one of those factors. To do full passwordless authentication, full multi-factor authentication, we want to do multi-factor. We want to use user verification to do a multi-factor auth. So I'm going to go down here and click on required for user verification. Now my YubiKey, all I've been doing so far is touching the capacitive sensor to specify my intent. However, some authenticators, as Matt mentioned, can also verify my identity locally at the same time through biometrics like a fingerprint or facial recognition, or if not through biometrics, by using a local PIN. Now, I don't have that set up on my YubiKey. So what we're going to see here is that when I go to register this new account and touch my YubiKey, it's going to fail. And that's because I've set user verification to true, and the website is now requiring that I verify my identity locally with my authenticator device before I can register for an account. So I'm going to stop sharing for just a minute, and hopefully you can see my camera again. I'm going to pull up my iPad and hope it's better at yeah, there we go. Fingerprint scanning now. I'm going to open Safari, and you notice we're here on WebAuthn.io, the same website. And so I'm going to type in, I'm going to do this part off camera because it's a little easier. All right. So I've now typed in the same username. You might not be able to see it. It says Jeremy3. And I'm going to go down to advanced settings, and I'm going to turn user verification to required. That says required, right? Yep. So now I'm going to go to register, and my iPad is prompting me, do I want to allow WebAuthn.io to use Touch ID? And I'm going to say yes. Let's please use Touch ID. Please use this fingerprint technology to verify my identity. So now it's prompting me to touch Touch ID, which I will do. And it let me in. I've now created this new account, and I can do the same thing with login. I have to select which credential I want to use, and then I touch the biometric scanner to locally verify my identity. Come on, there it goes. And now I'm logged in. And that worked very similarly to the user presence flow. It wasn't a whole lot of extra work, but it actually did multi-factor in one step. So user verification is a flag that the authenticator can optionally set in the response if the user verified their identity to the authenticator device while unlocking the private key. If it's set in the response, then the relying party knows that the user is is in possession of their authenticator device, which they knew either way. That's something they have. And they're either biometrically verified, something they are, or verified by a local PIN, something they know. Now, the relying party doesn't know which of those, but they do know that that the user was verified. And because this is truly multi-factor, UV logins with user verification turned on don't need a password. So we can do multi-factor without having a password at all, which is a great login experience. Now, you might also be saying, hey, Jeremy has these tools he's using to test out this site. He's got an iPad sitting there. He's got a YubiKey. What do I do if I'm sitting at home and I want to just play with this myself, or I want to get involved with WebAuthn and test this out? There's a really cool tool baked into Chrome. Now, it doesn't actually allow you to interact with a physical device in the same way. But if you open up the developer panel by hitting F12, Control-Shift-C, or another hotkey, I think you can get to it by going to the settings. If you go up here into the top right corner, you hit the little 3-dot settings menu, go down to more tools and down to WebAuthn. What pops up is
Jeremy, you share your screen again.
Oh, thank you. Apologies. Let me go back and redo that real quick. Sorry about that. And thank you, Matt. All right, so if I open up the developer tools page, oh, that wasn't there before. If I open up the developer tools page and go up to these 3 little dots in the top right-hand corner and go down to more tools, WebAuthn, what's gonna pop up is this really cool WebAuthn virtual authenticator environment. Now it has to be turned on every time because it's totally insecure. This is only useful for testing, but it's really useful for testing. So if I enable this environment, I now have a fully emulated authenticator available to be used on any website I want. So I'm going to go here and I'm going to go back through this flow one more time, and I'm going to register a new account. Now I have user verification still turned on and still required. And I'm going to say register, and you'll see there was no prompt for me to interact with anything. It just said success. We've now registered an account and a new credential. And over here in the credential list, a new credential has appeared. You'll also notice that sign count equals 1. So it's generated 1 signature using this credential so far. I'm going to hit login, and I'm automatically logged in. And you'll also notice the sign count has incremented to 2. So this is a really cool tool that allows you to set up this virtual authenticator, generate credentials on the fly, and use them even if you don't have any hardware to play with. That's the last thing I wanted to share with you, but I'm now going to hand it back off to Matt to show you how to get started developing a WebAuthn login experience yourself. Thanks so much. Take it away, Matt.
All right, thanks, Jeremy. So give me a moment to, I'm going to go ahead and share my whole screen here. Okay, and can you see my editor in the browser okay? Okay, I'm going to take that as yes. Yeah, thank you. All right, so excuse me. There's a lot of, the data structures involved in WebAuthn are not intuitive. They're not human friendly. And so, and once you start diving into the spec, there's all kinds of verification going on with, making sure the signature is correct and diving into these very, very compact data structures to try and pick out the bits of information from the responses, the authenticator responses, so that you can then kind of process it and figure out whether or not it was legitimate or not. And that's where libraries come in. Now, as with anything else, libraries are intended to make integration of technologies much easier. And so what I want to highlight is from a very practical perspective, like let's say you don't want to get deep into this stuff and you don't want to have to write this stuff from scratch, and I don't blame you. I want to show you what it looks like to integrate this into something resembling a fairly practical website. Now, what I have here on the right-hand side is my editor set up with a simple server that is intended to kind of show you how these login flows work, and it's kind of a test bed for this technology. So Simple WebAuthn is a node library as well as a browser library. It's a pair of libraries that enables you to integrate this into your JavaScript project, both the front end and the back end. And so what I want to show here is the most simple integration of WebAuthn involves the addition of 4 endpoints into your server. Now, as far as groundwork goes, WebAuthn assumes that you have some kind of user database. That's an absolute minimum. Depending on whether or not you do 2FA or passwordless or usernameless, you still need something to store information that comes back from the credential after registration, so that during login you can verify the signature that was sent back and you can know that the user has returned to your website. And so what this example server has is it's called an in-memory user device database. It's just, it clears out every time you restart. But what we're tracking here is user ID and username, some real basic properties. And then devices, the poorly named devices is actually where your credentials are going to go. And so, okay, sorry, I'm gathering my thoughts a little bit. And so what I want to show off here is the pairs of API endpoints that need to be added to your server in order to enable integration with a WebAuthn library. Now, as Jeremy mentioned earlier, WebAuthn starts with the generation of options, either attestation, which is the technical term for registration, or assertion, which is the specifications technical term for login. Now, you're going to, when the user comes to your website and they want to register, you're going to need to generate options. Now, the options are where the server has the opportunity to decide which level of WebAuthn integration they want to add to their website. And so you provide some, the helper libraries, have you provide some simple values, things like what's the name of your server, like what's kind of a human readable name, a unique ID that's usually the origin. So like, for example, this is localhost 8000. But if you were to deploy this to a website at example.com, your RP ID would be example.com. You need your user ID and a username so that you can show the username to people. The authenticator needs the user ID to be able to associate a generated credential to a specific user at a specific website. And then you have things like timeout, how long does the user have to do this, and various other properties, which are less important right now for sake of demonstration. What I want to emphasize here is that there's one endpoint that generates these options for registration, and there's another endpoint that will verify the authenticator's response to those options. And so these two API endpoints represent user registration. And so now a user comes over to this website, and the example server here assumes that the user has identified themselves already. So this is an example of 2FA and passwordless, where the user has provided some kind of value to the server saying, hey, this is the user account I say I am. And so it's just an empty UUID. And so the user comes here and they register and they provide the username and password, and then they begin registration. And so one of the things I wanted to show off here real quick was some of the, excuse me, the options will be a JSON body that gets sent over to the server. And so these are kind of what the library has output for the options that you provided to it. So now the front end gets those options, the browser gets those options, and it makes a call to the WebAuthn API. And the browser then prompts me to verify my identity with localhost, the website. So in this case, I'm going to choose built-in sensor because I'm on a MacBook Pro that has Touch ID. And I touch my Touch ID, and what happens is the browser, once the user has interacted with Touch ID or the authenticator in some shape, a response is generated that it gets sent back to the server. And so that's where this second point, this verify attestation endpoint, comes in. Now, the challenge, as Jeremy mentioned earlier, the challenge is used to prevent replay attacks because it's going to be a unique value every time the user performs one of these things. And so as a server developer, you're going to have to keep track of some of these values. You need something stateful to preserve certain values while the user completes their activation of their authenticator in the browser. And so in the example here, the options generation method here returns a challenge, which I've stashed as a current challenge on the user's entry in the database. So now down here, with the attestation response that comes back from the authenticator, I've pulled in the user's current challenge. I pass it into the method here along with the response, saying, okay, the response is going to have this value. It's going to have it should be from this website, and it should be with this RPID. And so then the helper library is going to verify the response, and is going to return back a determination of whether or not the response could be verified. In this case, it was a legitimate response that was verified, and there's some additional information about the response. I'm sorry, the authenticator rather, including its credential ID, which Jeremy mentioned earlier, this is the public key, half of the private public key pair that the authenticator generated for this website. And so now that the response has been verified, as a RP developer, as a server developer, there are some values that you need to persist. Specifically, at the most basic, it's the credential ID, the credential public key, and the counter. And so once you stash these values in a way that's specific to your server, to your setup, and I want to highlight that none of this is prescriptive. This is kind of gives you an overview of the general flow of things. You need to tweak this specific to the server that you're building. And so now my little demo server here has a record of my laptop, and I have registered myself as that 000 user. So now later I come back and I'm like, oh, hey, I want to log in. So here I am on login, and I've entered, again, 2FA or passwordless. I've provided some kind of user ID or bit of information about myself, and I want to yes, I'd like to assert that I am who I say I am. So now the server has the public key, and all the server needs is 2 more endpoints that are, excuse me, the general flow is the same, except it's just assertion this time. And so assertion has its own set of options, and assertion has its own verification process. And so just like we did with attestation, we're going to call the method that gives us our options that the WebAuthn API is going to expect. We store the challenge, and then we send back to the front end the options that we generated. And so when I begin login, we'll pause here and we'll see some of these options that it sends over. Here's that unique challenge that is going to be different every time. And so now we go ahead with this. And so the browser knows that the browser knows that I used Touch ID because the server told it that I used it for my user ID. So what I'm going to do now is I'm going to Touch ID, and now the browser takes the authenticator's response, sends it back to the server for verification, and here we see that the response was verified. And so now I'm going to go ahead and jump ahead through debugging, and now I've essentially logged in. Now without breakpoints, it's kind of interesting seeing how quick. One of the challenges as a developer is like, how do you communicate that this is more secure when users expect a little bit of friction with, for example, entering a username and password? And so that, as you start down this and as you start introducing users to this, you're going to see that one of the challenges is like that was way too quick. I touched Touch ID and I'm instantly logged in. Like, there's no way that worked. Something must have gone wrong or whatever. And so there are going to be some unique user experience challenges that you're going to have to overcome to educate the user that, yes, this is actually working as designed. It is this fast. It is this effortless. And the user never has to enter a password. I want to touch on the usernameless aspect a little bit as well, because you can kind of elevate things to the next level where the user doesn't even, like the first time the user comes, maybe you send them a magic link that starts the registration process. And at that time, you could generate a user ID for the user. You don't need to know anything about them. You just say, okay, authenticator, this is the user ID I'm going to assign to the user once they've interacted with you and I verify that your response is legitimate. And then the authenticator is going to remember that user ID so that the next time the user comes back, the user performs the login, this assertion flow, and the authenticator provides to the server the user ID. And so when that happens, the server is leaning on the authenticator to protect that user ID, which it can, it passes back with that whole signed message infrastructure. And so there's a lot of moving parts here, but the end result is that the server can essentially go to that next level where they don't really have to know anything about their users. And so it's even more secure from a user identity perspective. And so this is an example of the simple WebAuthn example project, which is kind of a test bed for the library as I work on it and improve it over time. But There's another resource that there's some of these debuggers. This is another one that I created. You'll see that when you generate responses and you kind of want to look at it and be like, all right, well, what's actually within all of these values? You can paste in a response. Like if you go into here and, ooh, that's very tight, but that's fine. Because I want to emphasize, if we go in here and we begin registration, no, I do want to register. Cancel. We'll go back. All right, so I'm going to do log in here real quick, and I'm going to interact with it. And so as you, here we go. So I'm going to copy, this is the raw response that comes back from the authenticator. And like, it's not human understandable. None of this makes any sense if you were to look at it, because it's all base64 encoded and all that fancy stuff. But you can paste it into tools like this debugger, and it will kind of peel it all apart and go, okay, here's information. The user was present. The user was verified because we use Touch ID. Here's the challenge. Here's where it took place, all that fun stuff. So there are lots of resources that are coming out now to kind of help you make sense of all of this stuff. And oh, let me stop sharing. Here we go. There we go. And so our goal is to kind of, again, with the information in the deck that we've prepared, we're hoping that it's going to be a good launch point for you to get more involved with this technology. So that is, let's see, you know what? I think that's pretty much it. I'd like, we'd like to open the floor for, Q&A, because I'm sure there's lots of questions that came out of this, and we'd be more than happy to go ahead and answer those. But before, one last thing I want to leave off is, if at any time you want some clarity on any of this, please feel free to reach out to either myself or Jeremy. I am Kale on Twitter, and Jeremy is JL Erickson on Twitter as well. And yeah, I know either of us would be more than happy to answer anything and help you start down this path. It's an exciting technology, and it's we're betting on it as the future of user authentication. So yeah, thanks for giving us a platform to kind of peel back the curtain, so to speak, and show you a little bit more about what's possible with this technology.